Hello, everyone. It's time to get started. My name is Adina Trufinescu. I'm Program Manager for Windows Phone Application Platform, and I'm here to talk about fast application switching. Oh, that's no good. More specifically, I will show you the user experience for resuming applications on Mango phones. I will talk about the application lifecycle and the concept of tombstoning. I will explain how the phone manages resources for applications in the background, and I will show you a quick demo. And I will end up with key developer scenarios. This is a mini session, which means that I have less than 30 minutes to go through this content, which is why I will kindly ask you to hold your questions to the very end. And if we don't have time for questions, I'll be in the booth at 3 p.m. in the Microsoft booth. So today on Windows Phone 7, when users navigate away and then back to an application, it takes a bit of time for the application to resume the previous experience. And during this, while the user is waiting, they are seeing the resuming black screen, or they are seeing an in-application loading content screen. And this is the experience that we are trying to improve. With the upcoming OS update for Windows Phone 7, also known as the copy-paste update, the application load time is going to be improved significantly, and that is going to impact positively the application resume time. But nonetheless, there is still a wait time, and there is still room for improvement. Let me just show you what I have here. So I have here two phones. This phone is running Windows Phone 7. This phone is running the Mango OS. And in the foreground, I have Fruit Ninja, the Xbox Live game, which I'm going to play with the purpose of showing you the resume experience. So I will start with the Windows Phone 7. So I will start playing the game. And then I will pause the game. And then I'll hit the back button to resume the game. And as you see the resuming screen, and the game takes a bit of time to load content. So while that is going on, let me show you the same thing on the Mango phone. So playing the game, slashing some fruit. I am doing good, apparently. And then I will pause the game and then resume the game. And then, as you can tell, I can resume the game and I can play right away. And let me show you this again. I will resume via the app switcher. Oops, I'm going back too fast. Let me resume, pause, and then the app switcher is here. I will resume the game, and then I can play right away. So, what is fast application resume about? To the developer, it's about enabling applications to resume the previous experience in less than 1 second. To the end user, it's about enabling multitasking and switching quickly among most recently used applications. This feature is going to be enabled for all applications compiled and built for Mango and submitted on Windows Marketplace for Mango phones, but it's not going to be available for Windows Phone 7 applications. To enable this for Windows Phone 7 applications, you'll have to recompile and test your application. We don't anticipate major changes to your application. In most of the cases, most likely you don't have to make any changes when you port your application. Nonetheless, it's very important to test your application on the Mango OS because of the changes that we're making underneath the covers to enable fast app switching. So let's see what are these changes. First, I will start by talking about the application lifecycle. And this is something that you are already familiar with, especially if you wrote a Windows Phone application. The reason I show you this is to highlight the changes that we're making to the application lifecycle to enable fast app switching. So the first application state is the running state. This is when the application is in the foreground. It has access to CPU and GPU to execute code and display on the screen, and it has access to phone resources such as microphone, camera, sensors, networking, anything. Life is good in the foreground. When the user navigates away, the application is being sent in the background and is being deactivated. And two things we want to happen here. The first thing, we want the application to have the ability to save state, which is why, same as today, the application will receive the page on navigated from event and the deactivated event handler, and it will have 10 seconds to save state. The second thing we want to happen is applications in the background should not have the ability to impact the foreground experience or to consume battery power. And this is the reason why today on Windows Phone 7, applications are being tombstoned, meaning that the process is going to be terminated by the OS. And this satisfies the two requests. The terminated process cannot impact the foreground experience, and it cannot consume battery power. But nonetheless, it has the side effect of the slower application resume. And this is what we are about to change. On Mango OS, instead of tombstoning the application, the process is going to be kept dormant in memory, meaning that the process is not terminated, obviously. The phone resources are going to be detached, and that's something that I will talk about. And then the application threads and timers are going to be suspended. So the application is in this frozen state where it cannot execute code, therefore it cannot consume battery power, and it doesn't hold on to any of the phone resources to impact the foreground experience, with one exception. And that exception is memory. And that is actually a good thing. It is the reason why the applications are going to be fast to resume when users navigate back to the application. Because when the application is dormant in memory, the process is already created, the frameworks are initialized, and the application state and content are already present in memory. So in that case, the application is going to be fast to resume, which is what I just showed you. To make it easy for applications to detect whether they've been activated after dormancy, we are adding a new property on the activated event args, which will indicate that the application process has been preserved, and in that case, the application doesn't have to resume state. Now, what happens when the OS runs out of memory? Because with applications dormant in the background, that means that at some point, the OS will run towards low memory conditions. So in that case, the OS is going to select the application, the oldest application, which is the application at the very end of the backstack, and is going to tombstone that application. And in that case, same as today, the user experience is going to be a bit slower, and the user will see the resuming black screen. And in this case, the property on the activated event args is going to indicate that the application has been tombstoned, therefore, it needs to resume state. So as you can see, the application lifecycle changes to enable fast app switching, but the application model doesn't really change that much. The application receives the same events and in the same order. When it's deactivated, the application receives the page on it navigated from, if it's a Silverlight application, and it receives the deactivated event handler. And same as today, the application needs to save page state or application state. And when the application is activated, same as today, it receives the activated event handler and the page on navigated to, and then it needs to restore state only if it was tombstoned. And that is also not different from what happens today on Windows Phone 7. Because even now, when the application shows certain launchers and choosers, the application is not going to be tombstoned. Or in the case when the user presses the start button and then they press the back button right away, then in that case, the application is not tombstoned. So what used to be the uncommon case on Windows Phone 7, which is activation without tombstoning, now becomes the common case. Or to flip it around, tombstoning used to be the common case, and now it's becoming the exception on the Mango phone. If your application today on Windows Phone 7 already handles the case when it is the case for activation without tombstoning, then your application is ready to go for Mango. All you have to do is a recompile. If your application doesn't handle this case, then in that case, you'll have to change a bit the code and to restore state only if the application is tombstoned. The next thing that I want to talk about is resource management. So take the example of an application which is using sensor motion, or motion sensor, or any other of the sensors, such as GPS or even the microphone. In that case, when the application is paused, we don't want the CPU activity generated in the background because of the sensor notifications. So in that case, we want the sensor hardware resource to be detached from the application. And there are two ways to accomplish that. The first way is the application does it. The application calls stop on the sensor manage object when it's being deactivated, and it calls start on the manage object when it's activated. But that means work. The other way to do it is if the frameworks detach the sensor resource underneath the covers. So when the application is deactivated, silently the frameworks are going to detach the sensor native resource from underneath the manage object, and then when the application is activated, the frameworks are going to reattach the object. Another example is an application which is using the upcoming photo and video camera objects. In that case, when the application is in the background, we really want the application to let go of the camera native resource, because this is an exclusive resource, and only one application can use the camera at a time. So in this case, same as before, there are two ways to accomplish this. Either the application calls dispose on the manage object when it is deactivated, or the frameworks are going to do so on behalf of the application. In either case, when the application is activated and the page is created, the application will have to create the manage object for the camera. So these two examples are at the core of resource management for Windows Phone 7, for the Mango OS. It's all about how the applications and frameworks work together to detach resources from the dormant application and to reattach these resources when the application comes back in the foreground. So let's see how this would work. Once the user navigates away, the application is deactivated and it receives the page on navigated from and the phone application service deactivated event handler. And this is where the application will go and save either page or application global state. But in addition to that, this would be the place where the application could stop the current user experience and could take matters in its own hands in respect to resource management. So for instance, if the application is using media player or media element, this is where the application would call pause. This is, again, where the application would stop the sound effect or the vibration, or in case of the camera, this is where the application would call dispose on the camera object. But if that doesn't happen, if the application is not coded that way, then that's no big deal. The frameworks are going to do so. Basically, when the application is done deactivating, the frameworks are going to enumerate the remaining resources in use by the application and are going to detach these resources. Examples of such resources are the XNA audio objects such as media player or the sound effect, which are going to be paused. For sensors, like I mentioned before, the notifications are going to be suppressed. For networking, for asynchronous calls on web client, HTTP web request, HTTP web response, or sockets, the calls are going to be canceled by the frameworks. The sockets are going to be disconnected. The media element are going to be disconnected from the media pipeline, and the camera objects are going to be disposed. The next step that happens is the frameworks are going to stop the application timers and is going to suspend the threads in the application app domain. So examples of timers are the XNA game loop and the XNA game timer, or the Silverlight dispatcher timer, the wait handlers with a timeout, or timer callbacks. So at this point, the application is in the frozen state, everything is suspended, there is no CPU activity, and the resources are disconnected. And the application is ready for the user to return to it. When that happens, the first thing that happens is the frameworks will resume the timers and resume the threads in the app domain. And then the application, the framework are going to attach the resources used by the application that have been detached by the frameworks on behalf of the application. And that is the general rule, with some exceptions, which is something that I will talk about. So, for instance, for the XNA audio objects, such as media player or sound effects, if the frameworks stopped or paused the playback, then the framework is also going to resume the playback. For the sensors on which the frameworks, suppress the notifications, then the notifications are going to be resumed. For asynchronous network calls that the frameworks canceled, then the frameworks are going to complete these calls with an indication of cancellation. The three types for which the frameworks will not reattach the resources are sockets, media element, and camera. So this is where the application will have to put a bit of work to reattach these resources. So when the application receives the activated and the onNavigated to events, this is where, if the application is using the media element, then it will have to set the source again, and it will have to set the position, and it will have to call play on the media element, either automatically or as a result to the user input. Then for sockets, the application will have to reconnect the sockets, and we highly recommend that the application does this asynchronously. And then the application will have to create the objects for the photo camera and video camera. So let me show you how this works in an example, in a real sample. I will get the application deployed on the phone. And this is a sample application which is using some of these resources. And my goal is to show you what is the user experience for when the application is using these resources and the application is paused and then resumed. Somehow I lost connectivity here, so give me a second. Let me do this. I won't deploy the application, but I have it already here, and I will show that to you without the debugger. So what I have here is a main page with links to other pages on which I'm using different resources. So let me start with sensors. On start, I'm using here the accelerometer, and on start, I'm going to start the sensor reading, and then I'm going to pause the application, and then I'm going to resume the application. So in this case, you will see that, as you've seen, the application is not only fast to resume, but the sensor reading has been updated right away. And this is a case when I didn't have to write any code to disconnect the sensor resource. I let the frameworks to do the work for me. Another example that I have is the Silverlight dispatcher timer, which I'm using to update the counter every second. And in this case, I will pause the application, and then I will resume it. And then the counter is going to be updated. And again, this is another case where I didn't have to stop the dispatcher timer. The framework stopped the timer on my behalf, and then it resumed once the application was activated. The other example that I have is the XNA media player, which I'm using to play local content. So let me check the volume really quickly. So I'm playing music here. I'm going to pause the application, and in this case, the framework stopped the sound for me. And then when I return to the application, the framework are going to resume the playback. So all these three cases are examples of resources where I do not have to put in any work because the frameworks are going to disconnect and reconnect the resources on my behalf. Let me show you one on which you'll have to put a bit of work, and this is the Silverlight media element. So what I have here is also local content that I'm playing. Let me bump up the volume. And when I pause the application, and then I will resume the application. This is where I had to write the code to resume the previous experience. So let me show you how that works in the code. When the application is navigated from, because I wanted to be a good citizen and to stop the music playback right away, then I'm calling pause on the video media element. And then I store the position of the video media element. And then when the application is navigated to, in this case, the source has been nulled out by the frameworks. And I'll have to reset the source to the same URI. And then when the media is done opening, I come here and then I set the position and then I call play on the media element. So this is what I wanted to show you in respect to a demo for how these resources are being handled by the frameworks. And as a cheat sheet, as the way to think about how these resources are being handled and what are to remember the things that you'll have to do about. The first category, we have the resources on which the framework does the work of detaching and then reattaching the resources. So in this case, the application doesn't have to worry about disconnecting and reconnecting the resources. The second category is the resources on which it would be nice if the application will take charge and it will pause the current user experience. And then resume on behalf, and then resume when the application is activated. But at the same time, this is your choice. If that is not the case, then the frameworks are going to do the work anyway. And then the last category is made out of the resources on which the frameworks provides the safety net for disconnecting these resources, but it is the application that will have to put a bit of work to reconnect the resources. So that's all I had in regards to resource management. It's a lot of information, and everything here is going to be documented. The next thing that I want to go through is the key developer scenarios, key things for you to remember. So when the application is deactivated, same as today, it needs to save state. And when it is activated, the application should restore state only if it was tombstoned. So it's important to check whether the application is dormant, and in that case, to not bother doing the application state restore. And if the application is using any of these resources, such as media element, camera, or sockets, then the application will have to attach the resources as needed. If an application is using launchers and choosers, when the launcher and chooser is in the foreground, the application is going to be dormant, which means that it will not have the ability to execute code. This is a change from the current behavior, where in the case when the application is not tombstone, then it still has the ability to execute code, something not documented, but developers figured it out. So if your application has a dependency on that behavior, when you port your application to Mango, you'll have to take that in account. And then run under lock. When you have an application in the foreground and the user locks the screen, then the application is going to be deactivated and it's going to be dormant. But if the application is configured to run under the lock screen, then in that case, it's not going to be deactivated and it's not going to be impacted by fast application switching. So same as today, your application will have the ability to execute code. And then last but not least, the debugger will provide the ability to simulate tombstoning. So we highly recommend that you debug your application when it is activated from tombstoning versus from dormancy, because both of them are equally important. And the debugger capability is exposed through Visual Studio. It's a setting in the project properties. Oh, excuse me. And then, like I said before, if you have an application already on Windows Marketplace, to take advantage of this feature, you'll have to recompile your application, test it on the Mango phone, and submit an update on Windows Marketplace. before the tools are out, the way to test your application and to check whether you are ready to go for fast application switching is by testing the scenario where the application is being paused and then resumed right away. So this is all I have. I will open now the floor for questions. Thank you. Yes. So good question. So what I showed you, and this is the case when the application is not using background agents. Actually, let me repeat the question. So the question is, you thought that the music will continue playing in the background. So is that the question related to the keynote? So that was IE via HTML5. But for applications in general, the music will be stopped when the application is dormant, the way I showed you. And if you want to continue playing music, you'll have to write a background agent, the audio background agent.
Is there somewhere that we can get the source for the sample that you just showed? And what about an example for the photo camera?
So the question is, can we get this sample? I didn't have plans to share it, but we'll find a way to share this through a blog. So I will share this through Peter Storr's blog. If you follow that blog, then I will make this available through that. For the camera, actually, for the camera, the way, just to explain briefly, the way you would do that, you would, when the page is navigated from, then you dispose the camera object, and then when the page is navigated to, then you create the camera object. It's not super hard, actually, it's quite simple. I'll come back.
Since there's not going to be local databases, will there be a need to close the database and reopen it when the app resumes? Or?
So in case of databases, everything that is still in progress is the transactions are going to be completed. Basically, the data is going to be written, everything which is in flux is going to be written in the database when the application is paused. There was a question here?
Yeah, you mentioned there's a setting in project properties.
That's right.
Are you able to demo that right now?
So the question is there is a setting in the project properties under the debugger tab, and am I able to demo that? I don't have it here on my laptop. It's going to be available when the tools will be out. It's going to be available, and it's pretty discoverable.
Is there anything we need to do in terms of XAML storyboards and animations? Like if you have like a long-running animation?
No, everything is going to be picked up from where it left.
Cool.
And actually, this is something that I want to mention for any of the objects. So I've talked about the objects on which there is resource attaching and detaching, which is going to, which means that the state of the object transitions underneath the covers when the application is deactivated and then activated. For anything else that I haven't talked about, the state of the object is going to be preserved, and then the frameworks are going to continue doing whatever they were doing. It's the same thing as when you hit a breakpoint in the debugger.
You had mentioned that web requests would get canceled. So does that mean like in your web request on completed, you need to check for canceled and,
yes,
and
that's right.
redo the call?
That's right. So in that, so the question is, oh, you've heard the question. So in that case, it's as if you have a network request in progress and you lose network connectivity. So you'll get a web exception or a socket exception, and the status of the exception is going to tell you that the request has been canceled.
Thanks.
Question? Oh. Okay, so we are out of time. I'll be at 3 p.m. in the Microsoft booth in the Commons. Then you can catch me up, and I'll be also sticking around here for additional questions. Thank you for your attention.